anyway, really pleased to be here. And as Rick said, been around the coatings industry a long time, even before officially able to be in the coatings industry. And so we'll talk a little bit about that. But really the premise of the talk is complaints to compliments. And many of you can't say you've never had a complaint. At least I know I've had lots of them. But how many of you had compliments about your paint finish? Don't be shy. Yeah? We're going to talk about what that feels like and what that is to be. But the reality is that we're a very, very foundational activity in the plant. We're not ones that people really understand all that well. It's even less understood at the boardroom level because paint's got kind of this, what really happens. And JD, you've been around a long time. You probably know what happens in that paint booth more than anybody, but you still had your days, right?
Oh, yeah.
Oh, yeah. So we're going to just walk through that. And I've got a lot of slides, but really what I have fun with is hearing about what you do. And I'm not going to put you on the spot, but I might because you're right here. But we don't want this to be drudgery. We want this to be kind of fun and interactive. And first of all, I got to get my slide to move forward here. Oops, do I have the wrong one maybe? Okay, they're setting me up already here. Well,
Try now.
Nope, let's try this other one. There we go. Okay, I don't know which one worked, but something worked. So anyway, we've been in the coatings business a long time. Come on in, guys. Come on in, guys. So my grandfather, I don't know if there's a pointer here on this thing. He's the guy right here, and he's responsible for this whole thing that we're in our company. He was a Dutch immigrant. He came over as a 16-year-old from the Netherlands, and he came over thinking about farming. And that was his plan, that was his dream, that was his vision. And so he made it to a little town in northwest Iowa that was kind of the last stop on the railway by the name of Orange City, Iowa. So we're right between Sioux City, Iowa, Sioux Falls, South Dakota, right in the northwest corner. And that's how we got to being there. And so he worked himself from a farmhand to getting a little land to rent, had some pigs and cows. In his last 3 years where the crops failed twice and the pigs died once, man, I better go back to making paint. So his father, grandfather, great-grandfather were paint makers in Holland. And Holland has a little reputation for paint, but he wasn't having that as a young guy, but he decided. And so today, we thank him for failing at farming. And if any of you guys know about Sioux County, Iowa, I know these guys do back here, our land is free there, isn't it? It runs about 20,000 an acre. At least that was the last time I checked. It's pretty productive. If he can't make it on that, he better not be farming. So we had a good time. But he started the paint business in 1926. And so next year in April, we'll be 100 years old. And so that's kind of fun. So here, I'm doing what I've been doing, but this is my dad at about 29. You can see he had his little pencil up there trying to show some states of Iowa there. But he was an engineer, graduated from North Dakota State in engineering. And so he was, of the four brothers, the one that really focused on the industrial business, which you guys are all part of. So I got to grow up in thinking about paint plants, but also more than that, he took me all over the Midwest. If I wanted to see my dad in the summer, we had to get in the car and go look at paint use in paint factories. So thankfully, I got a chance to see that. Today, fourth generation, and we have a fourth generation. Drew's daughter Mika's with us on our stockholder team. And thankfully, that was a few years back, and I've aged nothing since then. But anyway, we love paint, and we have a long history of it. But everybody has paint problems, and you can see even us. And so we're in this together. And when you talk about complaints, it starts with what we do, because we make the paint and powder. And so we get to have the starting point, and then we get to use it together as a group of paint applicators. So all types of problems. In the box or the bucket, even before you guys get a crack at it, from the box or the bucket, and that's why you're all here at Spray Equipment, because somehow we got to get this out of that box or bucket, transferred through your skill set onto a part. And then on the part, once it's all done, you guys have done your job. There's things that happen. Some things we know about, some things we don't, but big thing is are you prepared when you get that call? So who of you guys in the last month have had a call from somewhere saying, hey, this paint just isn't quite right? You guys got to be honest. See, the paint guys are raising their hands. Yeah, it happens. I mean, it's just, if it isn't the last month, it's in the last year, and everybody'd raise their hand. But the big thing is, what do you get that call? How do you react to it? How do you, go about your day after that? Is it ruin your whole day? Well, you hope not. But that's what we got to get to the point of having some confidence. So, in the box or the bucket. I have to admit this, but we do goof. So, it's just pure and simple. The material made it through all this QC, quality control, different steps, but it just isn't right. Maybe it was right a month ago, but sitting in the box or the bucket, things can happen. Things can settle out. They can separate. Paint's a whole bunch of raw materials that in reality, they just don't want to be together. We put all this energy in mixing and compounding to force raw materials to go together. At times, they just don't want to be. Maybe the formula's been around for 20 years, maybe it's been around for 2 months, but you just don't always know. But we try not to goof, but we do. Improper material storage. Who wants to put a box of powder at the top of a warehouse with no insulation in the roof in July? Who would like to do that? Anyone? Well, it's possible. It might be about 145, 50 degrees up on that roof line. What's going to happen to that powder? Billy? It's going to clump. So that's another thing. You can almost guarantee it. And then this happens especially with shops that don't do the same coating every week or every day. You can just get the wrong thing on the wrong part, or the wrong part B mixed with the wrong part A. Does that ring a bell? A and B, or this A and that B. Well, it can be just completely wrong material. And that's something we have to work together, is how do we mitigate that? How do we mitigate, 3 different part A's and 3 different part B's in your plant? I mean, it's pretty common, but it's so easy to get the wrong thing mixing together. So, other problems. Why won't it spray right? Anybody have any feedback for me on that? Why won't it spray right? Viscosity. Okay. And what does summer and winter do for you in viscosity? Changes? Yep. Any other? That's the number one answer. That one show, it's number one, number two answer. What's the number 2 answer for why it won't spray right? What was that? Dirty guns, yep.
Wrong pressures.
Wrong pressures. Too high, too low. What else? Humidity? Absolutely. We're just getting in that time of year where the seasons are switching. Goes good for 6 months. For 1 month, you can just struggle. 2 other things. At least 2 other.
Proper application.
Proper application, just for primer, yep, absolutely. They spray differently than top coats. It's just not the same. One more. So,
the wrong additives could definitely make a big difference in how it's going to spray.
Wrong additives, wrong solvents, or maybe not a solvent for that time of year. No, that's fantastic. Well, here's from a powder tip guide. What kind of spray pattern are you trying to produce? A conical pattern for more online, or a fan pattern if you're trying to do larger sheet metals? So what would happen if you have a conical pattern, which is a round one, trying to spray a gravity, big seed cart, lots of square footage? What would that do for you? Powder guys, I got to make sure you're here too.
Heavy edges.
Heavy edges. Is it going to be pretty uniform as you're going across? You know, usually conical ones, you get a little bit more on the outside of the circle. So what would you want to do? You'd want to go look and say, should we change to a fan pattern? So that's on the powder side. You know, this wrap stinks. I was talking to the Graco booth here. I don't know how they do it today, but 15 years ago, you could walk in a plant. I could tell if the turbines are running or not. Right? You guys experienced that before? I think they're quieter today than they used to be, but you could tell. But what's another reason wrap would stink? Poor ground. Or no ground.
Improper solvents.
Improper solvents. So fantastic. So this is just a list of solvents, and you guys can pick out the ones you use. But this column on the, to me, the way right, is your electrical resistances. And to me, and Rick, you're going to help me out with this, because we go back to number 2 guns. You guys know what a number 2 Ransburg is? This is ancient stuff. Lee. So number 2 Ransburg is the one that slowly turns. It's a gun about this long. And what's it used at, like locker?
Fencing, and it's driven primarily 100% on electricity.
Yeah,
So
it's
there's no atomizing air, there's no fluid pressure, there's nothing but electrostatic.
and a little bit of centrifugal. And so for that gun, you have to be absolutely polar. So that wants to be as hot can be in terms of solvency. But typically, the more regular guns, that'd be almost too hot for your turbine guns, your other ramped up electrostatics. So 2 things that I always like to look at is, you know, flash point is an indicator about how fast it evaporates. And so you can have a fairly good solvent for electrostatic, but if it flashes so fast, you'll lose your wrap because of the solvent flashing too rapidly. So then you might want to find something like a D100 that's a little bit slower evaporating to keep your material wetter. You know,
We want to be 140
yeah, and yet sometimes with the Graco turbine, some deader ones work well. It just depends on that evaporation rate and if the product stays wet or not. If it gets dry really quick, then you'll lose your wrap as well. So there's a little bit by guess and by golly, but because we're a bit of an art form when it comes to it, but my premise here is if it doesn't wrap well, you do have to kind of find out what that sweet spot is for flash off or flash time against electrical resistances.
Anytime you're using electrostatic you need to know what the polarity of the
Right. So I saw in the Graco booth, they had a polarity meter on their table. And so, like I said, it's definitely something you just don't want to go on autopilot. You want to work on what that optimum range is for your particular equipment. So then, like one mentioned here, if you don't have good ground, you don't create that full circuit. And that grounding is very important. And if you get a lot of hook buildup, typically that grounding doesn't do very well. So you guys do some burn off or some blasting or soda blasting of your hooks. So it makes a difference, doesn't it? And you can tell when you need to do it, but you don't want to do it, but you need to do it. Any other questions or comments on wrapping? It's fantastic when it works, isn't it? Makes it a lot of fun. And then on powder, similar things. You don't have the solvency to deal with, but you have to worry about your grounding, but also then with powder, you can actually be too aggressive if you've got a lot of inside corners that you have to kind of blend out how much power you want to put into your charge field to get the best overall wrap and application. So that's just a control panel. And there you got voltage and you got milliamps of resistance. And most of the modern pieces of equipment, you can adjust them slightly. Dave, I know that's what you do. You go out and find that. Where's that sweet spot? So, and then the paint doesn't hide at all. I don't know if I have a picture on this, but I hear this a lot in the wintertime when you go from warm paint kitchens to cold paint kitchens. And Bobby, you talked about thinning material. And it can be very easy if you got cold paint to get it to your number 2 Zahn cup of 30 seconds. You know, in the summer it took 1.5 gallons of reducer in your drum, and now it takes 4 gallons to get that same 20 seconds or 30 seconds number 2 Zahn because the paint's cold. And then you go to spray it and it warms up a little bit. It's like, man, where did my black go? This stuff doesn't hide at all. Well, you just thinned it out by 3 times from what you normally do. So, guys have experience with that? Oh, yeah? Yeah, I heard that. That's good. No, that's a real issue. And then if you don't think about it, it can catch you completely off guard. And then you're taking a drum of paint, getting an empty drum, putting half of it in, putting in half of what you just thinned down. And that's no fun, is it? There you go. So what do you do to keep it warm, Robert?
I have inline heaters and my systems are circulating
Okay.
back to the drum, so it's essentially heating the whole drum.
And so do you do that for a while before you go and check the viscosity? Like,
Oh yeah, that's one of the first things that started up.
so like 6 hours later, then you check it, or?
Oh yeah, check it at the halfway point of the day, make sure we're still on track with our day-to-day production.
Okay, did you guys hear that? So it's easy to just take it and run with it, and that goes back to us as paint manufacturers. Are we getting the material to you at 77 degrees at 25 seconds every time we make it, or is it 21 batch and 35 another batch? You know, we want to try to keep our tolerances, but ultimately you have to have that final check at the factory, which is your factory. Okay, well, on the part, no coverage in the corners. And that kind of lends back into some of these things that we just talked about. And this particular picture is a little out of sequence. But that kind of goes back to that this wrap stinks. And I was looking at what I was going to talk about today and realized that the version I sent them, there was a little out of sequence. But this is not recommended for having good electrostatic wrap. But also, if you had something that had more angular on it, it would really goof up just your overall uniformity of paint. But I was very, very regular in seeing this kind of part hook maintenance. This is maybe 15 or 20 years ago, this picture. And I think today there's a lot better management of hooks. It used to be just like pulling teeth to get people to work on their hooks. But it's just part of a good finish. But here's that inside corner. So who's heard about Faraday cage? Yeah, great, that's awesome. So that's just the basic premise that you've got kind of this field, and as you try to put paint or powder, doesn't matter which, into this corner with electrostatic, it's almost like 2 magnetic norths on a magnet coming together. And so the premise is that you can turn your electrostatic off if you're really concerned about that corner. Or on some of the modern systems today, you can go to half voltage like on turbine guns, or full, you go back to half, or you turn it down on your control panel. But this is a very common issue that you can get paint on it, but you don't really get that much paint. And so it can be a real weak area for corrosion. Anybody have any story about Faraday cage? Not such a big deal. But just remember, there may not be a lot of paint even though it's covered visually. And we'll talk about that with the device here.
That's where cutting in comes into play.
It does. Picture framing, reinforcing, getting all the tough spots, hit the first time around, and then you do your finish spray. And then you get another half coat in those areas, but at least you'll have it reinforced. Craters, defects, and no gloss. How does that look? That's more defects. Crap in the finish, Yeah, that's pretty like home like that. Now there's a vendor booth out here selling inspection lighting, which that's a fantastic tool. And some of these defects are not that easy to see in a dark factory. And so then you get it outside after you've had it all decaled, you're ready to deliver, get on the trailer, what happens? Oh, shoot, there's just more stuff in this coating. So, and then you get something like this. Should we ship it? No? Yes? Well, yeah. Well, this, this could be an orange peel kind of a reverse hammer tone type coating, but it's not. But it's amazing how much can come through your exhaust system. So, when you think about your spray booths, even if they're in the corner of a plant, but many times they're in the center because you keep building onto your factories and the paint lines don't move. Where's all the plant materials coming through? Yeah, paint booth. I mean, I don't see a lot of paint booths in industrial plants that are fully, air makeup right to the booth. They're usually drawn through sidewalls or booth ends, or, even if the air makeup's 40 feet away, they're not plumbed right in. So you just have a lot of opportunity to pick up everything. So, and it can be strange things. It can be, mold release from, maintenance guy doing some electrical work that's trying to do some wire stripping, and releases come off electrical insulation wiring, to somebody using something that they bought at Home Depot that may or may not should come into the plant, but they're doing it in the front office to spray and clean windows, to WD-40. I mean, I've gone on to full plant shutdowns because we had just a massive amount of cratering, in basically looking and doing an audit as you can, get 10, 15, 20 people just to look at anything and everything. And then they come up with, something that got bought from the local hardware store. And it happens every Tuesday on the third day of the week that somebody sprays something and it just comes in and just does its business. So that's why we'd like to get involved as soon as we can, but we also have to sometimes talk on the phone about what could it be, how could it be, and so what can we check to ensure that the part is painted right? Well, this comes into implant quality control, and this all is things that you all can do, and that is to try to get a measuring system to create some consistency. So you can see a wet film gauge, dry film gauge, and just checking the part for primer before putting the top coat on it. The reason I put the last two slides to, I guess, your right, is a contrasting primer to top coat. And that's really, really helpful to get your film thickness from your primer to your top coat. Because, in reality, you're only going to check the final coating system, not necessarily the coating layer. And so how do you know that you've really done what you need to do between both coats? So QC checks, talked about wet film thickness, and that's if you get something simple and you get 50% solids and you get 3 mils wet, you're going to get how much dry? 1.5 mils, okay? And so years back, we used to have more like 30% solid, so it took 3 wet mils to get 1 mil dry. So you got to check your TDS or your tech data sheets, and that's how you can use wet film to predict dry film. And that's just really something I would say at a minimum monthly, if not weekly, to have some program within your shop to just, if somebody asks, what's your dry film thickness, that you know it. And then you can go out and show. This is more on powder, but it can be on baking liquids, but just MEK rub cure test. And this is a oven profiler, which is a oven temperature recorder. And you can see the probes on it. You run that through your oven at your sequence. And then if you do your cure test, which is an MEK methyl ketone cure test, isn't always the same. And if you have your oven profiled well, it should be, but if you just do your quick test, because you don't do your oven every day, and if you have a breakthrough, it's like, oh, wait a minute. It looks dry, it feels dry, but it isn't dry. And so it's a good thing if you're doing powder coating or liquid that's dependent on heat to have an oven recorder for that reason. And then just dry and wet crosshatch adhesion. Dry is where you use a knife to cut it, usually at a grid, and then you pull a certain kind of tape off to see once if you have full adhesion or whatever you specify, because sometimes it's not capable of full adhesion, but 75% would be considered passing. But then wet adhesion is something as simple as taking a bucket with a panel that's sprayed and then just putting it in RO water, reverse osmosis water, for 8 hours or 16 hours after cure, and then just taking a good knife blade, doing an X-cut. Does your coating have good wet adhesion? So we'll work with you as a paint manufacturer because not everyone has great wet adhesion, but if it does, you can check that at any time you'd like. But that's typically where we see failures. Is it's all great when it's dry and not stressed, but you get a coating that sits in the damp, rainy weather for 2 weeks and somebody says, man, this coating is kind of peeling off. Well, it could be that it's pre-treatment dependent or it just never cured right, and that wet adhesion will be a stress. And so my dad would always say, you know, water is such an innocuous material. You know, we drink it, we love to swim in it, we like to do all these things, but water over time is the great destroyer. You know, it just seems so basic, but you put something in a bucket of water for 8 hours or 16 hours, and if it doesn't have a good stickiness to it, that water permeates most any film, some faster than others, and it's going to be, well, here's a good example. If any of you guys are bakers, you know, if you're going to roll dough out on the countertop, you don't want it to be a dry countertop. You want to have some flour on it, right? So that you can roll the dough out. Well, this is the inverse of it. If you've got a pre-treatment system and you leave a lot of dissolved solids on the steel when you're drying it out, that water is going to permeate that film and it's going to hydrate that dissolved solid like flour would on a countertop, and that paint's going to stick to that flour and not the countertop. And so it's a reverse of that, but it's just a great example that you want to have that paint sticking to the substrate, not something in between. So flexibility, impact is another one where you're trying to do some mechanical bending that can show some weaknesses, and just pencil hardness. Guys, we're all in school, number 2 lead pencil, 2B. Guys, remember that filling out the tests? I mean, that's getting to be old age now. But there's different hardnesses of that graphite, and if a coating's cured and it's spec'd to be H hardness, that pencil hardness is going to be able to tell you right away, did you get it cured? So those are simple things.
Hey, Mark, back to your wet adhesion.
Yeah.
Does it make a difference with the solvent-based material versus the water-based material, or are they pretty much the same?
Well, that's a good question, because certain coatings are more permeable to water than others. And so for a highly cross-linked 2-component epoxy, it may take, 3 days for that sitting in a bucket to basically get through that coating if there's a contaminant between it and the substrate. Whereas another coating that's an air dry, whether it's water-based or solvent-based, but a low energy cure, it might be 4 hours. But if the coating has good wet adhesion, regardless if it's a 4-hour or 72-hour kind of test, it's really to figure out, do you have good pre-treatment between the substrate and the coating, that there isn't some level of contaminant. And so then you got to make sure you have, with your coating supplier, a test article where you know that you have pre-treatment that's adequate, and then you go against your system and see once if they match. So it's an in-house test that can be done without any kind of expensive equipment. And it's just an indicator. It's not the end all, but if somebody says we got poor wet adhesion, we're going to think a little differently about how do we go after rectifying it or solving it. So that's a good question. Last thing I have just on QC checks that I wanted to show this is, who's heard of a holiday detector or an edge coverage? A few guys in the paint side. And so that's this device here. And what it is it creates an electrical circuit. And I love this device because it's really trying to figure out, do you have coating across the whole profile of what you're painting? And so it's really indicative of blasting underneath, but it can be just light in those corners that we talked about, like that Faraday cage. And so you can feel this, Billy, this is just a little wet. And then this is just a probe. And that's an old one. We call that the squawk box, but this one has more of an internal speaker. But it's basically creating an electrical circuit. So this is the electrode, and then this is your ground. And so on this panel, I had it sprayed on top of blast, lightly at the very top and a little heavier at the bottom, but it all looks black. And so if it works, it shouldn't squawk till I get up in the corner. And then what that's showing is that there's little peaks of the profile that are peeking through the coating and creating an electrical circuit. So that's on the edge. But down here, it's not squawking. I just knew it in that upper left corner. So how that helps you guys in an immense way is that you don't want to have it be where somebody says we got some corrosion up in this corner half a year later. You want to know about it the day you paint it. And so I just really believe in this tool that it's able to tell you that it's just low film build. Now, if you go to a dry film thickness, which I did yesterday in the lab before I came, it was within about 0.2 of a mil between here and there. But the profile of the blasting was a little heavier up in the corner. And so it's just a good insurance policy. So you guys have seen this. Now you know, but this is a good tool. And a lot of times you may not have this in your own factory, but it's just a good thing to ask your tech service or your sales rep if you got complex, if you blast, because I'll show you that on another slide, but you get this opportunity for these mountain peaks to peek through. Any questions on that? So, and then I know we have a pre-treatment person here, and I won't get so deep in it, but I just like to talk about removing sharp edges and scale, and that goes back to this holiday detector. Paint loves to flow, but the sharper the edge or the more perpendicular or 90 degree, more likelihood it is to come away from the edge. And so to ensure that you don't have picture framing corrosion, you need to get those edges covered well. And covered well may take some mechanical preparation to create just a little bit more like, it doesn't have to be rounded, but just create less of 90-degree angles on your edges. And then chemical wash, it just needs to be controlled. And that's something for you to go deeper into at some point, but these things are variables that affect if we get phone calls.
We'll demystify that process in a little while.
There we go. So she'll talk about total dissolved solids. We get that up in our part of the world in Northwest Iowa. We have very hard water, very hard. And if you go through and do your pre-treatment, but then you throw on our water as a final rinse, you're going to get a lot of flour on the countertop, a lot of hard water deposit, and that just does not do well with paint. So then we suggest RO, reverse osmosis, final rinses, sometimes deionized water, just to get those solids removed. Coating weights, that's a whole nother science. Copper sulfate substrate checks. Have you guys ever heard about this? Anyone? Pre-treatment, I'm sure. It's just a little kit that we produce, and I won't do it, but it's basically a chemical that if you're going to direct to iron, it will turn like copper like a penny. And if your steel, after pre-treatment, doesn't remove a preservative of steel shipment or something of that nature, it won't turn as a penny. And that's a real problem because then you're sticking to that preservative. And I know one of our major issues we had back in our dad's day, Rick, was there was a lot of steel coming from, at that time, Vietnam, some of those countries where they were really coming out with recycled metals. And it would come in, get mixed with domestic steel, and you'd have a preservative almost like a creosote or a Vaseline kind of jelly on the steel. The American steel wasn't. They'd go through and pre-treat it, not thinking about it. And then literally 3 months later, we'd have paint falling off on one part of the machine and not on the other. And this test really helped us because you go through the same pre-treatment process, but you really weren't taking the preservative off, even though visually it looked okay. But don't hear about that as much today, but it's just one of those tools to kind of verify and help you get down to the root of what you may be dealing with. So don't forget about that one. We talked about wet adhesion and then just surface profile. So if you're blasting and you're using hot rolled steel, you get that scale that comes from the mill. But then depending what your blast media is, what type and what kind of pressures that you use, you're going to create this blast profile, which is fantastic for paint adhesion because you can just kind of lock in like Legos in these peaks and valleys. But ultimately, to not have that machine go off, you need to be at a minimum a half a mil above the profile, if not more, to keep that peaks and valleys covered. And it's very, very simple to not do, to get enough paint on. So you guys have strategies about how you make sure you get enough paint on? Anybody gone through this? Who blasts in here? So just a few. So you guys that blast, how do you measure your profile? Profilometer. Bobby, can you guys give a little explanation how that works? And it puts a little pin in.
We shoot for about a 1 mil profile.
Which is, it's almost a beautiful satin looking, I don't know if you, yeah, and what would you say this is? This is probably like 1.5 mils here, but that's, yeah, and that's, and do you use shot or do you slag?
Round shot.
So you more ping it?
Yeah.
Okay. Does that make sense to you guys? Yeah. This kind of profile is used more like, media or sandblasting. It's very angular. A lot of times in inline blasting, it's more of a steel shot. So it's going to be more rounded. But still, you need to get that profile filled in. And yes, there's gauges that are really mechanical that just put a pinprick in it to try to measure between the peak and the valley. So anyway, I can't stress this enough because this is where we get most of our complaints of corrosion. Usually doesn't show up for 6 months, but you'll get this call. It's like, I got measles on my trailer. I got measles on my whatever I'm building. It's like, well, it's just a little bit of corrosion popping through. And then just, yeah, ongoing validation testing. These are more things that we would do to help you. But trying to do first articles or something similar to what you're doing, but on a test panel, and just monitoring your system 3 months, 6 months, 1 year, 2 years. Are you stable? Because if you get somebody asking, you want to be able to show, hey, we're doing our best to make sure that we have some stability in our process. So when you get the call, I like to say, stay calm. And when you get that field complaint, because you'll get it first, and I know you guys would raise your hands when you've gotten that call. It's like, well, how can this be? I mean, we did all these things, we tried, and many times it isn't something exactly that you think of, but once you get it out in the wild blue yonder, almost anything can happen. So I like to identify the environment. So if you guys manufacture in Kansas In the next 3 months, production goes to South Florida and Key West, but you've never sent things to Key West. A year from now, you might get a call because you just don't have experience in your product being in Key West. The good news is that if it only is in Key West, Florida, and things you've sent all over for the last 10 years haven't been there, you got a challenge for Key West, but you don't have just complete failure everywhere. So that's what I like to look at. Not that I'm looking to defend, but you don't want to go to bed thinking, oh man, the whole world's falling apart. Because we got enough of that in the world, right? Yeah, we got enough. So identify that environment. Yeah, film thickness is going to be the number one thing outside of the environment to check for. Do we got enough paint on? And then there's a corrosion rating system. And you can see from this, that would not be a 1 on a corrosion system. That'd probably be not good, close to 10. And then the more photographs and sampling you can get when the complaint comes. Not 3 weeks later, not 3 months later, but that day if you can. That is just what's totally necessary, because our premise is I'd rather have the problem go to the first slide where we goofed up. Short of that, we need to work together to figure out the best that we can. Is this an anomaly like the Key West, or is this something that 6 months before you've got 3 weeks of production that went off the rails? And so what do we have coming at us? You know, is there a way to mitigate it? Or how do we create a public relations message? I mean, all kinds of things. But how do we quantify? But if we don't get that data when that first complaint is called in, it's amazing how many times stuff gets thrown out in the trash, or the person doesn't work here anymore, or any of that kind of thing. And so I just want to encourage you by that. And photographs and sampling today, I mean, we can take phones and go right online with each other. I've done it across the world a few times. And it's like nobody thought about this. And I can tell you from a paint manufacturer's perspective, I want it to be my problem because we can fix it. But when you get into the point of trying to have that talk, it's not to create defensiveness or not, it's just to kind of brainstorm, because many times it's an anomaly that just wasn't even thought about, or you go back to production records and something was different on that day, and so then I like to say, you know, if you can duplicate it, you can solve it. And so if we can duplicate the failure, then we're going to have high confidence that if we find a fix for it, that's history. So that's how we're going to be motivated with each other. And so it's not to create, you did it, I did it, she did it, he did it. It's, let's figure this thing out. So, and then if we have to figure some way to mitigate the risks and the challenges and the costs and all that, it's much better if you've got a solution. Otherwise, you just throw it under the rug and hope for the best. And serendipity only happens once. I mean, that can happen. You get just something that you just will never, ever figure out. And I've been through that, but many times it comes back. Hopefully not to haunt us. But so anyway, that's some ideas I have for you. It's based on a lot of just being in your factories. Any other questions, concerns? JD?
I have a comment for everybody. If you get a phone call from customer service or from a customer complaining that when I wash my machine, the paint comes off,
Ooh.
the first question you want to ask is, what's the PSI rating on the pump you're using?
Absolutely.
If it's 3,500 PSI, you got a problem.
It's going to take anything off. Yeah, did you guys catch that? That's a great thing, because you get somebody with a 6,000 PSI power washer going in, and it's like they got, well, we got a customer that does a lot of cement work, and you get kind of dried cement on things, and I know they've had their customer want to come in with a 5,000 PSI power washer to get that kind of semi-dried out cement off. Well, it takes everything with it. And so, but you only do that once, and you don't do that again. Any other comments, questions? You guys have been a great group.
Documentation will help you
find a lot of problems.
So he just said documentation will help you find a lot of problems. And it may help you see it before you even have problems. So, and now today, I mean, there's so many ways to document. And I know I had that photographing, but you know, when I started in 1990, what seems like ancient history, we didn't have iPhones and smartphones and all these things. Getting pictures was you had to take a picture and go get it developed. And it's like you couldn't tell if you had a good shot of what you're looking at. But today you can use photos for a lot of scenarios. You know, my dad would say a picture's worth 1,000 words. Well, we don't have to write 1,000 words anymore. You take a picture, log it in, take a picture of your chemical ads, your solvent ads, and those things will be good documentation. So if you have that issue, you know, what was happening on April 4, 2025? Well, I got it. So now you got 3 questions already answered. Anything else?
Identify if there's any change in normalcy.
Yeah, that's really good. What's normal, what's not?
What's changed?
What's changed? And I know most customers say, well, you guys have changed, we haven't. And we say, yeah, that's good. But when you get into the midst of it, we find out that we both changed somehow.
I meant like, you know, daily stuff, or, you know, they got a new painter.
Yep.
You know, different guy mixing.
Different guy mixing. Yep. Yep. John did it, now Joe's doing it. Nope, that's good. Anything else? Otherwise, I'll be around here for a while. Love to talk with you. Guys that we do business with, thanks. We love it. We love paint. Hope to stay at it for a while. 100 years, not so sure about that, but got to keep our kids interested, you know. That's always something. Anything else? Good enough. Well, thanks. Appreciate it, and have a good rest of the day.